Inequality symbols function as directions for location on a number line. They tell us exactly where one number sits in relation to another. Take the comparison of -3 and +1. We read this less than symbol as is to the left of. When we look at the number line, -3 is located to the left of +1, making the statement true. Grounding numerical order in physical space keeps our focus on the line itself, rather than the specific digits in the problem. This becomes particularly useful when comparing two negative numbers, like -2 and -5. Imagine these as temperatures on a winter morning. It is a common trap to see the digits 5 and 2 and assume the 5 represents the larger value. Pause the video here, sketch a number line, and plot both numbers to see which one sits further to the right. When we map them out, we can see their true relationship. -2 is positioned to the right of -5. On a number line, values further to the right are greater, so -2 is greater than -5. For negative numbers, the value closer to 0 lies further to the right, which makes it the greater number. We can apply this same spatial logic to variables, such as x is greater than -1. The symbol tells us to look at all values to the right of -1. -1 is our boundary point. Because the statement is greater than rather than equal to, we use an open circle to show that -1 itself is not part of the solution. The variable x represents any number that exists in this direction. Algebraic inequalities map out a region of possible values relative to that boundary point. To keep these positions clear, we can use two direct translations. Greater than means a number is to the right of another. Less than means a number is to the left. Look at these 2 points on a line. Point A is placed to the left of point B. Based on their positions, how would you write the inequality that describes the relationship between point A and point B?